Okay, so in part E, we're asked to find all price pairs that can occur in a separating PBE. So again, we'll follow the same steps as we did previously. So in a separating PBE, Monica will set a price for the low quality flat, which is not equal to the price she posts for the high quality flat. She'll post different prices uh, for for each flat. Um, the beliefs corresponding to this strategy of Monica's, um, well, we have let beta 1 be the probability the customer places on the flat being a high quality flat given pH has been posted, that is 1. And then beta 2 the probability the customer places on the flat being a low quality flat given PL was posted, and that is also 1. Okay. Now basically we have to consider the customer's best response to these beliefs. So in particular, what does the customer play in response to PL? Okay. Okay. And what does the customer play in response to pH? Okay, so let's consider the customer's best response to PL first. Well, if PL is posted, then the customer's expected utility, a customer of type theta's expected utility from renting is theta minus PL. So this is greater than 0 if theta is greater than PL. So you're going to rent if your type is greater than equal to PL, and you're going to not rent if it is less than PL. Okay, moving on to the second case. The customer's expected utility, if they rent a flat posted at price PH, is going to be theta plus 1 subtract PH, which means that you rent the PH flat if your type is greater than PH minus 1, and you do not if your type is less than PH minus 1. Okay. Now we move on to our fourth step, where we're basically considering the appropriate ranges of pH and PL that basically preclude any deviation from equilibrium strategies. So there are two classes of deviations we have to look for in the case of a separating PBE. So the first class, basically, Monica could post the high quality flat at PL instead of PH, so we could have a deviation from PH to PL in the case of the high quality flat, and then a deviation from PL to PH in the case of the low quality flat. So these are called, we could call these imitation deviations, where either where Monica basically imitates the price she posts for each type. Or rather, she sort of just switches the prices posted for each flat. So this is, let's call this class A of deviations. But then we also have a class of deviations wherein Monica might change the prices of either type to some price other than PL or PH, right? So we could have Monica change the price of the high quality flat to some P dash, and the price the low quality flat to some P dash where P dash is not equal to either PH or PL, and call this the class B of deviations. So now basically we have to calculate equilibrium utilities and off-path utilities, and this will basically help us find equilibrium ranges of PL and pH. Okay, so first, what does Monica get by posting the low quality flat at PL? Well, she gets PL times the probability that the customer accepts or rents, which is the probability that theta is greater than PL, as we saw from the strategy specification above. What about the corresponding off-path utility? That is to say, what does Monica get if she posts the low quality flat at PH? Well, she's going to get PH times the probability that theta is greater than or equal to PH minus 1. Right, again, this just follows from the strategy specification above. Okay, so this is the corresponding off path. Okay, what about the Mary's utility from offering, rather from posting the high quality flat at the price PH? Well, she's going to get PH times the probability that theta is greater than or equal to PH minus 1. Okay, what about the corresponding off-path utility? That is to say, what does Monica get if she posts the high quality flat at PL? Well, that's just going to be PL times the probability that theta is greater than or equal to PL. Okay, so these are our class A of these are the utilities we'll well, actually, okay, this is off path as well. Okay, now what does Monica get if she posts the low quality flat at some P dash not equal to PL or PH? Well, she gets the probability that, well, okay, so we first have to specify what the customer believes when they see some flat posted at P prime. Let's say what they believe about the quality of that flat. Let's define some belief beta 3 as probability that the flat is of low quality given the price P prime, and let's say that's 1. Again, we're trying to make the off-path beliefs as harsh as possible so as to make our separating equilibrium as easy as possible to support. So okay, so we have